Hello, Dr. Sue. This is Jeremy Hood, accompanied with my partner, Brittany Cook.
Hello.
We are here to present a short survey presentation on web mining. We're going to proceed with myself performing the introduction, as well as going over one of the categories in web mining, as well as some algorithms and models. Following that, with the conclusion, Brittany is going to speak on some of the categories and processes with web mining, some future and current studies. And that should be about all for this presentation. So let's go ahead and get started. The introduction. So web mining is a technique within data mining that is used to extract information and knowledge that is located on the web. It is tightly coupled to data mining, so you'll see a lot of the same techniques and algorithms used. The size of the data that's being evaluated on the web is extremely large and has by far surpassed any kind of human computations or evaluations for that matter. So autonomous or semi-autonomous mechanisms are needed to evaluate the data or process the data. Data is usually stored in two different ways. You have structured data and unstructured data. Structured data is easily searchable, if you will, so similar to HTML or XML tags, whereas unstructured is pretty hard to search and it's not usually form-fitted. The web data stored on the web is primarily unstructured, which makes it a little more difficult to search. Hence, we need algorithms to do that for us. Historically, web mining has been focused on the extracting patterns of interest from web pages, concentrating on the website content, structure, and usage of those websites. As we can see by the diagram, there's three categories that are associated with web mining. So it's web content mining, web structure mining, and web usage mining. This presentation will go into a little bit more depth on each one of these categories or processes, but we will certainly keep it high level to save some time. So let's move on. Each of these processes or categories serve a specific function. They target specific data, and they also target a specific area within the web or a web page. Content obviously is focused on content of that web page. Structure is more focused on the actual structure of the web page, whereas the usage is more focused on how a user uses that website or web page. Some of the uses for web mining that make use of these processes or categories for various operational gains are the following. So we have recommendation systems for user personalization within a website, web fraud detection, or not really prevention, but more detection by picking up on patterns. We have corporate decision making based on historical data. So searching historical data within, like, let's say e-commerce purchasing logs, so that way they can see common things that were bought or purchased together. Walmart certainly uses this to group their items within their facilities to obviously promote more purchases, as well as Costco. Process mining, which is more of a future task about how things are done, not necessarily the data, but the process of doing such. Capturing various metrics and measurements on the web. This is more of experimental type testing. We're like using surveys and stuff, but with live data and real users. I'm going to hand it over to Brittany now to speak over our first category of web content mining.
Web content mining is traditionally a technique of searching the web via content. The primary mining source today is search engine or web browser logs to see what content is being searched. Web content mining primarily focuses on data content, and this is beneficial to businesses when making decisions and trying to increase efficiency. There are two approaches used in content mining. The first is agent-based, and this includes numerous AI agents acting autonomously or semi-autonomously to perform mining. Three of these examples are intelligent search agents, information filtering, and personalized and semantic. The second approach is the database approach, which is a well-formed database containing a well-defined schema and attributes that contain defined domains. With the agent-based agent, it automatically searches for information according to a particular query using domain characteristics and user profiles. An information filtering and categorizing agent, the information agent uses a number of techniques to filter data according to the predefined instructions. In personalized web agents, the web agent learns user preferences and discovers documents relating to those user profiles. The second approach, the database approach, contains a schema as well as defined attributes that make the mining process simpler. The mining of a database is not just interested with the data within the database, but the types of data stored. The schema involved. The database approach is tightly coupled with the inherited data mining field. This figure shows the structured, unstructured, and semi-structured data and all the categories associated with content mining. Semantic web mining provides classification and clustering of contents to facilitate a knowledge-based response and highlight unnoticed patterns. Classification refers to the mapping of a data mining into one of a number of predefined classes. Clustering is the process of grouping together a set of items having similar features. The end goal is to construct clusters of data that are neither too narrow, where everything is too broad, or there are too many clusters with only one or two items in a cluster. Finally, the clusters are often used to gather closely grouped or clustered items to be presented in a recommendation system. Fuzzy web mining is one mechanism used to mine content within a web page. As most data on the web is unstructured and difficult to evaluate, it is necessary to transmit it to a human-readable format in which evaluation tools can be applied. Fuzzy logic processes uncertain, incomplete, and imprecise information because of its simplicity to model human reasoning. Classical mining techniques may not always work if the data being evaluated is too vague. This is because the data may not be able to be placed into a cluster. So fuzzy mining is used for clustering information together that is not crisply classified.
I'm going to take back over on this one for the web structure mining. Again, web structure mining basically creates a web, almost like a spider web, if you will, of the interconnected links by finding and categorizing pages of data by similarity or ranking. One focus on the interrelations between data. Providing a link graph among websites is basically how this web is created. This is accomplished through searching through hyperlinks for patterns in the link structure and grouping websites together. Of course, there are other mechanisms to do such, but two main focuses that we used in our survey papers were the structure of HTML and XML tag usages. Using HTML and XML tags within an algorithm basically undiscovered relationships between web pages can be found, and this is useful in recommending or filtering search results. One of the algorithms that we looked at is called HITS, or a hypertext induced topic search. The second is PageRank, which we will now discuss a little bit more in depth. Hypertext-induced topic search, or HITS, works by utilizing a rating scale of authority, basically the content value, and a hub value, which is the quality of the links to the other sites that it's connected to. The rating scale is calculated by starting with the root data set that you can see on the right-hand side in the center, that consists of the top pages returned by a text search algorithm. This is followed by expanding the root data out by locating all of the web pages that are linked to it, thus forming a base set of data, which is you see on the right side on the outer perimeter. A final hub authority score is determined by iteratively executing authority update and hub update calculations an infinite number of times. So it continuously does this. And the point is to basically determine the relationship score of the top topics searched, hence providing similar topics. Everyone has at some point Googled something and have gotten really good hits, and then gotten some that you're wondering, how did Google even come up with a relationship between what you searched and what you returned? This is a result of probably a poor authority score or a hit based off of this algorithm. The next algorithm that we looked at is PageRank. It's an algorithm that determines the value of a link by how many other websites are linked to it. The figure to the right displays an example of the sample rank scores based on a generic Google search. The rank score of a page is evenly divided among its outgoing links in the beginning. The web page is assigned a high rank if the sum of its backlinks rank high. We can see this on the right-hand side figure by seeing that the node B has a very high score because it has a lot of backlinks associated with it, whereas A has a very low, and of course all the blue on the bottom that's associated with E has very low as well. E has the second highest because it has the next smallest amount of backlinks. The ranking keeps going in an outward fashion, as you can see in the figure, that links that do not directly link to the initial page can still link to outgoing links. The idea here is that the node B that has the most backlinks, obviously the next layer has items that share common relationships, whereas further down the tree, you eventually get to where they don't really have any ties to the original search, but are somehow linked to intermediate links. I'm going to hand it back over to Brittany to talk about some web usage mining.
Thank you, Jeremy. Web usage mining shows who or how many people followed the link. Web usage mining is also interested in how people use the web for websites. It improves efficiency while allowing the user a personalized experience. And this is achieved through weblog mining, which analyzes the behavior of users. Weblog mining is the mining of log data located on web servers and application servers. It's comprised of 4 steps: data collection, data pre-processing, pattern discovery, and pattern analyzing. This process can be seen in the figure on the right. Web content mining is a traditional technique of searching the web via content. It's primarily focused on mining content on the web to find patterns. Web structure mining focuses on the interrelations between the data among websites. It's primarily used to discover the structure of a web page to find interconnected links and provide recommended sites or personal filters. Web usage mining is focused on the mining of log data located on web servers and application servers. It's primarily used for personalization and recommendation systems.
Now I will go over some of the algorithms and models that we personally researched in this survey paper. And we will start by explaining a little bit of what algorithms and models are referring to. So data aggregation from various sources of various types require different types of objects to be stored or processed. Once the mined data is collected, it must be placed in models in order to perform actions on the data to locate the desired pattern or value. 3 common models used for data processing are the association models, clustering models, and classification models. Brief description of each are: association is used to identify relationships and associations between data to locate patterns. Clustering attempts to cluster objects into groups based on similar characteristics as well as objects that are not similar. So basically you got similar and unsimilar in 2 different clustering nodes. Classification categorizes objects that are similar in functionality by evaluating attribute classes in the object's classifier construction. So now we'll look a little bit more at association. Association models and algorithms are used, as the name suggests, to find association or group data by associations. This survey evaluated the a priori algorithm and the frequent pattern growth algorithm, also known as FPG for future reference. A priori is an associative rule mining algorithm and array-based data structure algorithm that has the advantage of being able to handle large amounts of memory, therefore making it very efficient. It utilizes a breadth-first search method to find frequently used item sets by moving on to the next layer after finding neighboring nodes in the first layer or first stage. It holds the property that if item sets are frequent, then so are all the subsets. The distance of the item sets are extended by a single item at each stage, leaving the most uncommon on the edge to be pruned. Priority is calculated using the following three measurements. You have the support that provides a fraction or fraction of transactions and shows frequency. It can locate items that have minimal frequency and filter them out. The confidence tells us the amount of times A or B or whatever the data points appear together based on the number of times A occurs. Lift reveals the strength of a given rule or determines a value based on the terms. FPG, frequent pattern growth, is basically an enhancement of the priority algorithm. They work very similarly and they ultimately have the same goal. FPG has just been optimized to run more efficiently by only evaluating pattern fragments in 2 passes over the data instead of scanning the data repeatedly, being very recursive. The next is clustering. Clustering algorithms attempt to cluster objects into groups based on similar characteristics. This survey evaluated 2 types of clustering, namely the fuzzy and the hierarchical. Fuzzy clustering, as Brittany had mentioned earlier, evaluates data that does not fit in a particular cluster, but unfortunately can fit into numerous clusters. This means the data does not distinctly fall into one cluster, hence making it fuzzy as to which it belongs to. This survey evaluated the fuzzy C-means algorithm, which randomly chooses the number of cluster centers. Then a summation algorithm is used to calculate the fuzzy membership of the data. Then a differential rotation, a different ratio, of summations is calculated to find the fuzzy centers. This will cluster the data sets based on their distances and values. Hierarchical clustering groups objects in a hierarchical fashion. There are 2 approaches. There's a bottoms up approach and there's a top to bottom approach. The top to bottom starts with a single cluster and splits based off of the distance between the single cluster. Bottom up is the opposite, where we start with independent clusters and work towards a single cluster. So if you'll think about the top to bottom as a basically normal tree with roots, if you will, whereas a bottom up is upside down. In the end, a dendrogram can be created to see the hierarchical tree of clusters. This survey evaluated an agglomerative or bottoms up approach. This is done by calculating the Euclidean distance between the data points recursively and calculating the complete linkage to identify the clusters. This is done until the distance matrix is complete, therefore identifying all of your clusters and how the hierarchy is formed. The last one is classification, which is a supervised learning method used for web mining the data during the discovery phase. There are numerous classification algorithms and techniques. However, this survey evaluated the K nearest neighbor. The KNN technique uses an object's neighbor's number of votes in order to classify. Based on this vote, the object in question will be assigned to a class that is associated with the K nearest neighbor, as the name suggests. The steps to perform a classification using KNN are: you load the data, you choose the K value, which is basically the parameter that defines the number of neighbors to be evaluated for the data point. You iterate each data point and perform the following. You find the Euclidean distance of the training data, sort the training data values in ascending order, choose the top K entries defined with the K value, and then you classify the test point based on the majority of classes in the K entries of the training data. Choosing the K parameter must be done carefully, as it can result in overfitting within clusters, basically making it more fuzzy, if you will, than form fitting. I'll hand it back over to Brittany now to talk about a little bit about the current state of web mining and some of the future in web mining.
Thank you. As the users on the web continue to grow, the need for web mining is as strong as ever. The need to autonomously or semi-autonomously process data on the web is a task that is still being researched and practiced. Shown below are some of the latest subject areas that have gained speed in the field. Process mining is the solution of extracting data for automation, as well as providing detailed information and details of the decisions that were made by the user during an action. Web fraud is high on the web due to the ambiguity of users and actions. The ability to use web mining to examine and identify familiar and novel fraudulent activity on the internet has become a high topic of interest. Web metrics and measurements can obtain and understand the viewpoint of its users, and the usage data or process can be greatly improved for efficiency. In order to do so, behavioral patterns must be evaluated and processed. The web provides a real-world test bed to obtain real user input without their knowledge in order to gain real-world metrics versus a test environment where the user knows it is an experiment painting the results.
Thank you, Brittany. So we have reached the conclusion of our web mining survey presentation. I'd like to close with that there are different techniques and mechanisms used to locate and process the data on the web residing in the topics of web content mining, web structure mining, and web usage mining. This survey paper examined and presented basically only a few of those techniques, algorithms, and approaches. There are, of course, others which may be used depending on the need, the data being processed, and the situation that the data resides. It is important to understand that the data is considered as valuable an asset as any piece of hardware or software that is out there being used. Therefore, understanding the data and being able to extract patterns, relationships, or other associations can produce great business gains or improve user experience. Therefore, it's certainly in the interest of any corporation to understand the data, process the data, and use this data to gain a competitive edge that makes you want to use their product or improve their web page or website that is user-friendly enough that draws you to use their product versus a competitor. Or the last is to basically improve the structure of the content, the structure of the web page to the point to where it's more efficient than others, to where the results are either returned faster or the experience is just more fluid. With that being said, this concludes our presentation. I hope that everyone enjoyed it. Thank you for your time and goodbye.
Thank you.